Okay, so here in this example, we are asked for what intervals is f of x, which is x squared minus 9, positive, and for what intervals is it negative. In order to do this, we gotta first know what positive and negative is referring to. Positive and negative, since it's talking about the actual function, is referring to the y values. So I need to first identify where it changes from positive to negative or negative to positive. So those are the x-intercepts, or they're also called zeros. So first identify x-intercepts. So I can see the x-intercepts right here at -3 and right here at 3. Now what this does is it separates the graph into 3 separate parts. So I'm just going to draw a vertical dotted line to emphasize that. So there we go. And the 3 parts that it's referring to, this is the first part, second part, and third part. Okay, so those are the 3 portions of the graph we're going to be looking at. After we identify the x-intercepts, second thing we're going to do is we're going to identify the intervals. Created. So the first interval there starts, since the graph runs off, we assume it keeps going. So the first interval starts at -infinity and ends with the first x-intercept, which is -3. The second interval will pick up at the x-intercept. So it picks up at -3 and goes to the next x-intercept I have there with a green line, which is 3. And the last one picks up at 3 and goes to +infinity. My graph runs off, so we assume it keeps going. So those are the 3 intervals we have here. And then the last thing we have to do is identify which ones are positive and which ones are negative. That was a horrible P. Okay. So positive and negative refers to the y values. So looking at the first interval, my graph is right here. I'm tracing over it a little bit darker. If we just take any one of those y values on that line as a sample, you can see that even right here, that y value is a positive y value. So that first interval is positive. I know these x values in the interval itself are negative values, but the positive and negative descriptor is not about the numbers in the intervals, but rather the value of the function on that interval. And the value of the function is positive because it's above the x-axis. My second interval, tracing over it there, is this portion here. If you take any one of those x value or any one of those points on the line as an example, you would see that it has a negative y value. You can also just tell by looking and seeing that it's below the x-axis. Since it is below the x-axis, that second interval, -3 to 3, is negative. In the last portion, once again, you can see we are above the x-axis there. So we are once again positive. Typically, they will alternate between positive and negative, but that is not always the case. It is a typical occurrence, but not always the case. And that's it. Okay, so we have the function g of x graphed below. On what intervals is the function positive, and on what intervals is the function negative. So just going through the 3 steps we used before, the function is, or we're going to identify the x-intercepts first. So I have 2 x-intercepts on this particular graph. Here are the 2 that I have. So that's going to split my graph into 3 portions. I'll just kind of highlight the portions. I do want to emphasize this one doesn't run off the side of the graph. It actually has endpoints. So it's not going to go all the way from positive and negative infinity. It's going to start and stop at specific spots. There we go, and our third portion is over here. So, we've identified x-intercepts, and we can see that it split the graph into 3 portions. Second thing I'm going to do is identify the intervals. So the first interval is starting at -2. We have an open dot there. And we're going until my x-intercept, which is at 1. So we're not going to include the x-intercepts because they're neither positive or negative there, so just be aware of that. The second interval will pick up at 1 and go until 3. And the last interval picks up at 3 and goes until 4. Now, unlike most of the other intervals that we have had, because this one is ending and not going all the way to infinity, on top of that, it has a solid dot as that endpoint. We need to include that endpoint in our interval. So there are our 3 intervals. Now we just need to separate them into positive and negative. And we can do this just by telling whether it's above or below the x-axis, or you can just look at specific y values. My first portion, highlighted in purple, you can see it's down here below the x-axis. Therefore, that first portion is negative. The second portion is above the x-axis, and therefore is positive. And the third and last portion, you can see once again, is below the x-axis. So that third portion is negative. I say this again, I know that this example also alternates between positive and negative. It happens frequently, but it's not a guarantee.